Hi there, it is time for PF4 Cs, which is Functional Notation Part 1. This is one of those things that you might see in another course, business, anything to do with statistics, definitely if you go into your sciences. And I just want to give you a little bit of exposure right now, so that if you see it again, you're not scared. If you see it on the final, it's not a big deal. And I tried, so honestly, it's one of those topics I find hard to, I don't know how to ground it. To me, it's just, hey, it's some cool math. Let's do this. But I'm trying to make it more real life. So bear with me. Let's give this a shot. Skippy got a new summer job. He earns $17.50 an hour. How much will he earn in 10 hours? Well, you are all clever. I suspect a lot of you just did that in your head. So we take the 10 hours and we multiply it by 17.50, $175. Excuse me. 40 hours. No, I don't want to do that in my head. But it's the same thing. 40 times 175. Whoops. No, try that again. 40 times 17.50. All right. Oh, just so we're clear, I want to make sure that we all know that 1750 times 40 is also 7 hours, right? Because when you multiply, the order doesn't matter, whether it's 40 hours getting paid 1750 or getting paid 1750 for 40 hours, you're still going to get $700. Okay, so part B, what determines how much Skippy will make at his new job? Don't get all fancy. We're going to assume that his rate of 1750 is stuck. So what really determines how much he's going to take home is, it's the number of hours. Oh, in the old days, kids, this was the number sign. Before it was the pound sign and before it became hashtag. Okay, so number of hours. So we could create an equation that looks like this. Like that. So pay is equal to 1750 times T. And if you were doing a spreadsheet, something in Excel, you could actually do it, and then you would just keep putting in different numbers for your T, and it would calculate out your answer. Another way, and this is where we're going, is you could write it like this. Now, everybody gets scared when you see this, but it's honestly exactly the same as that, just written slightly different. So you say P of T, or P is a function of T, is equal to 1750 times T. Oh, by the way, if anybody's wondering, no, you do not need the 0 on the 1750. You use 17.5. And there is no profound reason why there's a space here and no space here. That's just a note with my typing. Okay, so what this means is the amount of pay depends on, is a function of time. And here's the connection. It's 17.50 times time. It's just a weird sciencey thing. So people get all excited. Then they see this. Then we're going to do the equation, because that just looks weird, right? It's simple. All right, so talking about pay, so I'm going to use the pay equation. So P times T is equal to 17.50 T. I'm just rewriting the equation, and I realize I didn't flip to a capital P. Meh, no big deal. So what I'm going to do now is, instead of the T, I'm going to take the 4 and we're going to put it there, and I'm going to put it there. So P at 4 is equal to 1750 times 4. So P at 4, oh yes, I should say sometimes it's of T, or you could say at T, because I realize I'm saying P at 4 is going to be 17 times 4 I should have been able to do that in my head. And we're done. See, this is the part where people get messed up. That little 4 there is just telling me that basically we're talking about 4 hours. So this is pay for 4 hours is $70. Do not divide by this 4. It just stays there. It doesn't do anything. It just reminds you what you're doing. Okay, 70, done. End of story. So try it again. I'll do it right. P of t is equal to 17.50 t. So P at 30 is equal to 17.5 times 30. 30. Ta-da! That's all there is to it. Okay, no big deal. All it is here's the rule. Oh, okay, pause it. By the time I have a drink of tea, you guys should have that question done. Right? Instead of t, we're putting 2.5. 17.5 times 2.5. Okay, so P since we're talking about money, I'll put the $20 sign in there. Make that bigger so it doesn't smoosh into my 3. Ta-da! And there we go. Okay, so again, the biggest thing, this, leave it alone. You're so used to solving for the P, because you know what, if you go back and you divide by 30, every single one of these is going to be 1750. So don't do that. We're done. Okay, cool. Now, I struggle to find a real life example. I went through about 4, I spent an hour. That's all I came up with. So we're going to talk about kinetic energy of a baseball. So kinetic energy is the amount of energy it has because it's moving through the air. Okay, so what does this mean? When you see your notes, there'll be a little something else written there, that the V stands for velocity. Otherwise, this doesn't make any sense. And perhaps I'll even throw some units in there. Okay. So the amount of kinetic energy something has, oopsie, a baseball has. Depends on its velocity squared. Right, that's the little squared part up there. Like I said, when you get yours, it'll have velocity written in there and a little more explanation. I forgot that part. All right, so we're going to determine K at 5. So K at V is equal to 0.075 V. Oops, didn't need bracket. K at 5, 0.075 times 5 squared. 0.075 times 25. K is equal to 0.075 times 25. 0.875. This is the look of, I need some units. I'll put another purple mark. One, joules. I believe it's joules. I was going through my brain. Is it newtons? Is it watts? And I think it is joules. Joules is kind of like a metric version of a calorie. All right, let's do this again. Oops. So K at 10. Yeah, just put J for joules. Okay, so how do the answers compare? Well, it's kind of cool because, excuse me. Yeah, okay. So I'll double check something. My brain says if I double my speed, the amount of energy something should have should be twice as much. It should double too. But that squared part actually means it increases even more. So the velocity of a baseball, the harder I throw it, it's not if I throw it twice as hard, twice as much energy. It's actually if I throw it twice as hard now, let's check this out. 7.5 divided by 1.875 is it's 4 times. It's not double, but it's 4 times the energy, which I think is really cool. Okay. So how do the answers compare? When double the speed, get 4 times the energy. Okay, so that is function notation part 1. And that's going to be the end of the video because there's a part 2.